Okay, welcome grade 11. Let's look at equations and exponents. Now, before I'm going to start, you have done completing the square this year. I'm not going to do that with you because it's not part of the syllabus in grade 11, right? So completing the square, you will only be doing next year. I know you've done it. I know it's in the textbook, completing the square, but they never ask it in the final exam, right? So this is for next year, and specifically we do it with circles, right? That's where it belongs. Right, the first one. When you see an inequality sign, what must you think of? Let's just look at all the summaries. Inequalities, what do? You set everything equal to 0. And then you must find the critical values, right? The critical values. And if you interpret it from the left side, let's say it was x squared, whatever. And if it's greater than 0, it means it's bigger than 0. Then I always say you are big, so you can go out. So see, this is a little circle. And then you look at the critical values. You use common sense. If this was a -1, the -1 will be before the positive one, if that was 5. So you are big, so you can go out. So you look at the values on this side and that side. If it was x squared something something, and it was smaller than 0, then what would you do? You would look at the values on the left side where it's smaller than. So critical values, smaller than means that you are still small. You cannot go out, right? So it will be the values to that side and to this side. So let's look at the first one. It's a greater than. So because it's an inequality, I'm going to set equal to 0. And then we're going to factorize. So you can still factorize using the formula, or you can factorize doing the normal factorizing. If I must look at this, it's 5 times 1. So I'm going to look at 5, which will give me 10 there, but let's see if I put it on that side. Then it's going to be 2 times 1 is 2, 1 times 5 is 5. I need to owe 3 in the middle. So I can say I owe 5 and I have to. So the minus goes in there and the plus goes in there. So there's your 2 brackets, 2 minus 5. You just add an x and 1 plus 1. Right, then we find the critical values. So the critical values will be 2x minus 5. You treat it like an equal sign. But the critical values you don't do underneath your sum. You can do it right here on the side. So x will be equal to 5 over 2. That gives me 2.5. Or x is equal to -1. So if you think of your drawing now, the drawing is just there to help you, but show it on the drawing. Sometimes they do give you marks for showing drawing. It's bigger than, so you are big, so you can go out, right? And it's greater than, so it means it's not included. It's like an open bracket. So on the outside, what would be the values of x there? It's going to be where x is smaller than -1, and the x values from there to the right side is going to be where x is bigger than 2.5 or 2,5. Next one. I sit here with, oh, you know what? I see now with this one, the typist didn't realize it was an exponent. Right. Now with these type of sums, what can you do? You can treat it like a normal trinomial and it will freak you out less, right? So you can treat it like a normal trinomial. So I'm first going to do that. Okay, I sit with 5 and 3. So firstly, what do we normally do with the x square? We divide the exponent by 2. And 2 divided by 2 is 1. So do you see what happens here? The exponent in the front is actually the one that goes next to this exponent in the middle. So that exponent actually comes here. You see, that's what we normally do. 5 times 3, well, I need to owe 2. So I will owe 5 and have 3. So x plus 3 will be equal to 0, or x minus 5 is equal to 0. Enough of that. We sit with this one. So how would we factorize this? Well, half of, if you take a half and you divide it by 2, because that's what we basically do when we factorize. You divide it by 2. That gives you 1 over 4. So you can just basically remember that when you see these exponents, which are fractions, you literally just take the middle one, and that comes here in the front. So to break up the x to the power of a half, it's going to be x to the power of a quarter in the one bracket, and x to the power of a quarter in the other bracket. And if you multiply this again, it will be x to the power of a quarter times x to the power of a quarter. A quarter plus a quarter gives you 2 quarters. And that is 1 over 2. That's a half. Sure. All right, so then it's going to be x to the power of a quarter plus 3, because I already factorized it there, and x to the power of a quarter minus 5. Then this is going to be x to the power of a quarter, which is equal to negative 3, right? And if you sit with a negative there, and this is an even denominator, it means you cannot get there's no solution to this. Why? Because that denominator is actually, you can treat it like a root, and you can't get the fourth root of a negative number. So this one, you will just write there no solution. Or x to the power of a quarter is equal to positive 5. And for this one, I can get a solution because there's not a negative in front of my 5. So what do? You just say to the x to the power of a quarter times 4 over 1. And this is 5 to the power of 1, which you will say times 4 over 1. Let's quickly see what is 5 to the power of 4. 625. So you only have one solution to that one. Right. Then let's look at the next one. Simultaneous equations. You will normally, with simultaneous equations, you name one equation number 1 and the other equation number 2. Lately, it has been quite popular to create exponential equations first, and from there you have to do simultaneous equations. Right, so be on the lookout. Then if it's the exponential one, you just simplify it and then you work from there. Right, what is the easiest one to get alone here? Well, it's easier to just get your x alone. And because I've changed this one, I'm giving it now a new name, number 3. Now I always write it on the left side and on the right side. So now I know you always sub the left into the right. So I'm going to sub this one on the left side into the one on the right side. So in the place of x, I'm going to write 1 minus 2y. You see, but it's x squared plus y squared plus 3. And then there, in the place of x, you just write your 1 minus 2y. So it's 3x. Very often pupils forget then to write the y there. You see, we subbed in into the place of x, but there's still a y. Do the normal foiling. Please don't mess up your foiling. My matrics forget how to foil, and you can also make the careless mistake. So if you are scared that you're going to forget, write out the brackets twice. I owe 2y and I owe 2y, so I owe 4y. It's only if you know that you won't mess it up that you can do it. Otherwise, rather spend like 2 seconds and quickly write it out twice. Rather be safe than sorry. What is the problem often here is because there's a y at the end. I will maybe play it safe, put in the extra step, and put your y in here instead of messing it up. Right? Let's see if we can't start simplifying. I owe 4y and I have, no, I can't do anything with a 3y because I'm still multiplied in. 4y squared plus 1y squared gives me 5y squared. So let's simplify that. Now I'm going to safely distribute in. Right? 1, I owe 4 y's and I have 3 y's. So I owe 1 and I have 1. Okay, my y's are gone. 5y squares and I owe 6y squares. So I owe 1y square. Nice and easy. Difference between two squares, 1 minus y, 1 plus y. So from that, one y is going to be positive 1 and the other y is going to be negative 1. I have seen in the past pupils do also forget to actually sub back in. So you've got now the y values, so you must still sub in to find the x values. You can sub into any one. I'm just going to sub it into this one, equation 3. You don't always have to say where you're going to sub it in for this last step. You can just show this. So if the y value is 1, it's 1 minus 2, so it's negative 1. Or if the y value is negative 1, okay, where do pupils make common mistakes? Common mistakes with the simultaneous equations would just plain be with an example like this one, where they forget this y, where this becomes a mess. They forget how to FOIL and they make mistakes with the signs. That's it. That's the basic mistakes I always see. Okay, exponents. Whenever you see an exponent, you must think of the following. You always break down into a prime number. If it's only multiplication, you take everything up, you write it on one line. If it's only multiplication, you write it on one line. Typically, they refer to this as type 1. If you see a plus and a minus, like I'm seeing here, right? What do? You give each exponent its own base. And then you try to make the bases the same. Each exponent gets its own base and you have to look for the common exponent. Common exponent. Right. This is type 2. Type 3 is when you see equal sign exponential equations. And that's basically when you try to make the bases the same and then you can drop the bases. Or it would be an equation like what we just did in the previous one. You know, if it's a equal sign, but it's with a exponent, and then you just treat it like what we did, you know, like a trinomial. Okay, this is type 2. So we're going to give each exponent its own base. 3 to the power of m times 3 to the power of 1. Okay, then the concept with this is to try and look for the common exponent. Let me write neater here. The common exponent. Right, and what is the common exponent? 3 to the power of m. Why do you look for the common exponent? Because you need to simplify and you need to cancel out, you see? So you take the 3 to the power of m, and what will remain? 3 to the power of 4 minus 6 times 3 will remain. 7 times 3 to the power of 2. So this will cancel out. And the top one, you're just going to put that into the calculator, and it's going to work out to be 1, the final answer. Right, so you just put it into the calculator. This one, whenever you see a question like this with different type of exponents, you always work with the smallest one. Work with the smallest. Can you see it's still a type 2? You see, so we're still going to look for a common exponent. What is the smallest one? Well, 2 to the power of 2005. So I'm going to break this one into 2 to the power of 2005. Why? Because I'm looking for a common exponent to take out. You see the concept? It's still the same rules. You look for a common exponent. Now, if I write this as 2 to the power of 2005, I need to multiply it with 2 to the power of 2 so that it still stays the same. Because if you multiply the bases, you will add the exponents. 2005 plus 2 gives me 2007. This one I'm just going to rewrite, you see, so I sit now with a common exponent that I can actually take out. So I'm going to take out 2 to the power of 2005. And please write it. Don't just skip it and do it in your head. Because if you do it in your head and you skip the step that I'm doing now, what is the danger? The danger is that you're not going to write a 1 there. You see? Because you're taking it out, so you must write a placeholder there. So this is gone. What will remain? 4 minus 1, which is 3. And that's your answer. It's just square root of 3. Next one. For which values of p will this one be defined, right? Now, when is something defined? Defined is when it's okay, right? It's when it's okay. Undefined is when it's not okay. When is something not okay? Well, there's quite a few scenarios. This is going to be not okay if it's 2 divided by 0. When will it be not real or not defined? If I sit with a square root that has a negative in it, then it's not okay, right? Then it's basically non-real. It's not really the same thing, but if this is a positive on the inside, it's okay, or we can say it will be defined if everything inside the square root is positive. Right. It will be defined if the denominator, if this one is bigger than 0, right? So if this is equal to 0, it's undefined. If it's bigger than 0, it's fine, it's defined. Okay. So when will this be defined? They're not asking when will it be undefined. Let me do both. It will be undefined if p plus 2 is smaller than 0, and if p minus 4 is equal to 0, then it will be undefined because I can't have a negative inside the square root. So that will be when p is smaller than -2, or if p is equal to 4. When will this be okay? If the square root is bigger or equal to 0, because there's nothing wrong with the square root of 0. That's fine, it's defined. So this will be defined if the square root is bigger or equal to 0, and you must find the actual values for p. P plus 2 is bigger or equal to 0, p is bigger or equal to -2. Or if p minus 4 is not equal to 0, then it will be okay. So if p is not equal to 4, then it will be okay. Okay, then this one was super tricky. You know, I normally just go through my files and I look for nice questions. This one was super tricky. It's like a level 5. Okay, so let's analyze. What shall we do? We must show that b is equal to ac over a plus c. So you want to have b in terms of a's and c's only. So let's see what's given. 3 to the power of a is equal to 21 to the power of b. And 7 to the power of c is also equal to 21 to the power of b. So from this, keep in mind then, if those two are equal, it means 3 to the power of a will actually be equal to 7 to the power of c, for what it's worth. We always break down into prime numbers, don't we? So I can break down 3 to the power of a into the 21 to the power of b. We break down into prime numbers. So I can write this as 3 to the power of b times 7 to the power of b. Right. Now, what do we want to do? We want the b alone. We want the b alone. So it's going to be slightly tricky. So I'm going to help you with this, right? So what we are going to do is we're going to multiply the exponents with c. We're going to multiply all of these exponents with c. AC, 3BC, and 7BC. Right? Now, what do I have here? I sit here with 7 to the power of c. 7 to the power of c. Right? I can substitute 7. What I'm going to do here, I'm just going to write this as 3 to the power of bc times 7 to the power of c. And you see, I can write that b on the outside. Okay, I know it's complicated. So 7 to the power of c, I can substitute with something. I can say 7 to the power of c. I don't want to substitute it with 21 to the power of b, then I'm back to the basics. But what did we see here? We saw that 7 to the power of c is actually equal to 3 to the power of a. And remember, it's exponents with the equal sign. So the guidelines that I gave you, you need to make the bases the same. You see, we try to make the bases the same. So I can substitute this 7 to the power of c with 3 to the power of a. Then just add the b there. So at least now we can drop the 3's. And what would you do with this one? If you multiply the bases, you add the exponents. Right? And I can now, you always think factorizing, factorizing, factorizing. So you can take the b out. And there you have it. So then you just divide the AC with your C plus A. Okay, I know it was super tricky. So how would you approach a question like this? You still break down into prime numbers and you try and manipulate. You try and see what you need to get a loan and you analyze everything that was given. Right, okay, that's exponents then and equations.